Let's talk for a moment about designing functions. There are lots of different functions that do the same thing, but some are better than others because they're easier for people to read and understand, and also because they're more useful in more situations. Now, there was a time when people programmed without functions. They just had statements, and the statements would tell you to go to other statements, and the whole thing was just a mess. But now, we have functions, and they're universally accepted as the right way to organize large programs, at least in part. So designing them is an essential skill for anyone who wants to work in computer science. Here are some characteristics of functions. A function's domain is the set of all inputs it might possibly take as arguments. A function's range is the set of output values it might possibly return. So knowing the domain and range of a function tells you where it can be used, what kind of thing goes in, what kind of thing comes out. Finally, a pure function's behavior is the relationship it creates between the input and the output. Let's look at some examples. We have the square function that we've been talking about for a long time. Now we have the Fibonacci function, which computes Fibonacci numbers. What's the domain of square? Well, it's any real number x. What's its range? Well, square always returns a non-negative real number, meaning positive or 0. And what's its behavior? Well, the return value is the square of the input. It's pretty straightforward. Okay, so we describe it in this way just to say what kinds of things come in and out. For Fibonacci, n, the input, is an integer greater than or equal to 1. It returns a Fibonacci number, and the return value is the nth Fibonacci number. Now, Python doesn't necessarily force you to specify the domain and range in code. So these are conceptual aspects of what a function is meant to be used for. And oftentimes these issues appear in the documentation. So you see, compute the nth Fibonacci number for n greater than or equal to 1 here. Here's a quick guide to designing functions. These are just heuristics based on experience, but they hold up in lots of different situations, so they're worth considering. One is, give each function exactly one job. Another is, don't repeat yourself. The dry principle. Implement a process just once, and then you can execute it many times. And finally, define functions generally. So I searched the internet for some images, and here's what I came up with. It's a good idea to model your functions after scissors, which have one job, which is to cut things, as opposed to a Swiss Army knife, which has many different functions. If something has many different functions, it should probably involve many different functions, not just one. Don't repeat yourself because it's a lot of work. Puppies are also a lot of work, here, in quadruplicate. And define functions generally. So here's a counterexample of what you shouldn't do. When the world defined electrical sockets, they solved this problem in lots of different ways. And for that reason, we have all these crazy adapters in the world, and it's really hard to plug stuff in. Instead, wouldn't it be nice if there was just one general way to plug something in? That's what you should aspire to with your function, not the chaos that exists in the electrical outlet world today.